Alright, let's talk about some triangle theorems. And really there's not a good way to introduce this other than just diving right in. So the triangle proportionality theorem says if a line intersects two sides of a triangle and is parallel to the third, then it splits the two sides proportionally. What on earth does that mean? Well, here I have a triangle. Ta-da. And I want a line to intersect two sides of a triangle and be parallel to the third. So I'm going to draw that line. So this line is parallel to that line. It splits the two sides proportionally. So if I call this A, this B, this C, and that D, A is to B as C is to D. That's it. That's all it says. So maybe let's say that this is 1, 2, and about 1, 2, and 3. Then I can use this formula and say 2 is to 3 as 1 is to something, whatever D is. And I can use the cross product and say that 2D equals 3, and solving, dividing both sides by 2, I get that D is 3/2. Because they're all proportional. Now, this having a fraction as one of them can be a little confusing, but it's still a number. I mean, that's 1.5. So 2 is to 3 as 1 is to 1.5. I mean, you can also say 2 is to 1 as 3 is to 1.5. It really doesn't matter how you set it up. But that's what it's saying. That A is to B as C is to D, or A is to C as B is to D. Doesn't matter how you set it. And that is the triangle proportionality theorem, right? Yeah, big words. The other one is the triangle angle bisector theorem. It says if a line bisects an angle of a triangle, then it splits the opposite side proportionally to the adjacent sides of the triangle. A lot of words. So let's draw a picture. Triangle. So a line bisects an angle of a triangle. So let's say we bisect that angle. Specifically, so this angle equals that angle because it's bisected. So that those two angles are the same. What it's saying is that if this is A and that's B and that's C and that's D, then we can say A is to B as D is to C. A is to B as D is to C. So it splits the opposite side proportionally to the adjacent sides of the triangle. So another way I could do this is maybe B is to C as A is to D. So this side is split proportionally as to these sides. These two halves, or not halves because they're not necessarily the same, these two pieces of the opposite side are the same proportion as the two adjacent legs, or the two adjacent sides to the angle that you bisected. So, yeah, either one of these works. Either A is to B as D is to C, or B is to C as A is to D. You can either read them A is to B as D is to C, or A is to D as B is to C, or B is to C as A is to D. Doesn't matter, as long as you go the same way, should be good. And that's the triangle angle bisector theorem. Proportions, they're everywhere.